Hi friends, welcome to my YouTube channel. Today I am going to discuss about how to debug SIP and web debugging with tools. Basically, wireshark, tshark, tcpdump. These are some tools which will help us in debugging the SIP and web protocols and debugging the voice issues, capturing DTMF. So I am going to discuss all this in details today. So before going to discuss, I just want to remind that please give like, share, and subscribe to my channel so that I will get encouraged to uh, release more videos like this. So let's start now. So those who are very new to SIP and wire protocols, RTP protocol, RTPs. So I have released another video, which the link is here. You can see the link here. So you can go through that video and you can easily get beginner's knowledge from this video. So this will give you some good idea how SIP, VoIP, RTP, all this works. So this is totally a beginner's guide. So guys, let's start with today's topic. So basically these are called sniffer tools. Now what are the sniffer tools and what it does? Sniffer tools basically reads data from the Ethernet and it stores in a file. It reads those data in protocol format and it displays those data to human understandable format. So this is what Sniffer tool does. It can analyze, it can capture any kind of protocols, and it can show it to the viewers in human understandable form. So there are various kinds of sniffer tools are there, but basically the most for our purposes for debugging the C, VoIP, all these, we have mostly widely used are wireshark, tshark, and tcpdump. These are the tools mostly used all over the world, and these are free tools available in internet. So basically these are the tools commonly used, but some of the companies they use their own tools, but these are some free tools available in internet and comes with various these packages are free to download and use. So let's start with tools like Windows. We mostly use wireshark, so this wireshark is mostly available in this link and you can download and install wireshark latest version from this link. So let's see in Google. If we search with so here you will find the wireshark website where they have given the installer and all this, so you can download and install those installers. So this is for Windows Wireshark. Then we can have Ubuntu or Unix platform. We can install the tcpdump Wireshark. So these are the commands used in Ubuntu for installing tcpdump and Wireshark. So how to use Wireshark in Windows? So let's see one example. I have already installed Wireshark in my system. So here it's already installed. So I have started Wireshark. So this window will not place. So here is the interface. I can select the interface on which I will capture the trace. So any of the interface through which you will send data you want to capture. So you can enable, you can select that interface and you can start. So it will start the interface and capturing. You can stop whenever you need to stop. So there are various filters you can put here. So this I will show you gradually. So this is how you can capture the data. So once you enable the data, it will start capturing the data. So here you can start capturing, you can stop capture. So this is how it works, the wireshark. I will give you the details one by one. So now let's talk about Unix or Ubuntu system. So how this works? So this is the command for starting the tcpdump. It will get the full captures. I is the interface name and hyphen w will do with hyphen w you can put the pcap file name. So here you can mention the interface name as well if you want to capture on any specific interface. Any will capture on all the interfaces. So let's see an example. I have some tools here. So here, so I started the TCP dump. It will start capturing the data. So here, if I see, so it captured. It captured some data. So test7.pcap is created. So similarly, tshark command is like this. So it will capture the capture all data. Now let's talk about some rolling pickup. Uh, so what is rolling pickup? Basically, when there are huge number of traffic is there, like thousand concurrent calls are running, and you cannot capture all data in one pk file. It will become huge and it will be very difficult to download or open. So what we do these cases, we run rolling pickup. What rolling pickup does is it uh, basically creates the file based on size and number. So if here I have mentioned the file size will be 100 and total number of files will be 100. So when the file size will be 100, it will create a new file. So basically this way it will roll the files until 100 files are created. Once the 100 file is created, it will override the oldest file. So this way it will keep rolling. So whenever this is very useful in production environment debugging purposes, where we will create 100 where there will be huge traffic and we have to capture so while running the traffic we want to debug some specific time uh, uh, pickup data. So there what will it will roll the pickup wherever we want to get the data. That will be that file will be like 100 MB file max. So that can be easily download and open in your system. So this is how this is the tcpdump command. This is tshark command, which will this here I have mentioned the file size is 550 MB and total file is 100. So here every 50 it will create 50 MB file and it will roll to next file. So let's see how it creates. Now if I copy this command, so it started creating file. Now see the file name here. So it created file with some number. So at the end it will give a number. So this way it will increase. Once the 100 MB file will be created, it will move to next file. This way it will keep increasing the file names. So it will create up to 100 files. Then it will start uh, overwriting the oldest files. So this is how the rolling pickup works. Now let's focus on the let's when we are capturing the data, there is requirement that there may be data coming from different ports, different host. So so we can filter the data on port. So if I will mention port 5060 like this, it will capture data from 5060 ports only, in and out data from 502 and from data 5060. Similarly, you can mention the host name, host IP. So it will capture from the specific IP only. So if data is coming from hundreds of IPs, it will just filter out this data and it will store this in store data from this IP to this file only. So this is the command for tcpdump. So similar command is here for tshark. So tshark also can do the same thing. So let's now focus on how to filtering and downloading a specific packet. So it's very important, like when you will capture 100 MB file, there might be one call you want to debug and one call you want to share with the customer. You want to filter data on. There are various reasons, like you don't want to show all IPs. You want to filter specific IPs and send it to customer for uh, debugging purposes. So all these cases, what you have to do, you have to select filter on specific IP and ports or specific conditions, and whatever data you have filtered out, this you have to save in a new file and you can share those files. This is where the filtering and downloading specific packets comes. So let's see how to do filtering. Now let's see here. I have captured C packets here. So I have lots of packets: TCP, DNS, SIP, STP. So instead of all these, I want to filter these calls. There are lots of data is there. Out of this, I just want to filter this call. So prepare filter. So now I have filtered only the media and signaling and media related stuffs in this filter. So now how I will save this? So there is option for export specified packets. So from here I can export my specified packets. So I can give a new name, filters.pcap. So I have saved it. Now I remove this filter. And so all data is here, but I'll open that filter.pcap. So this is my filter.pcap. So it has only those data that I have filtered with. Those. The rest of the data will be not there. So this is related to this specific call only. So this is how we do the filtering of specific call, specific port. Based on the conditions, we do filtering like this. So now see. So now see how to merge multiple pcap files. Merging is very important. Say when you are running a rolling pcap, it might be long duration calls are there, where media will be separated in two different files, signaling will be separated in two different files. So this case, merging is required. You have to merge multiple files to one and get the ultimate full call flow from that merged file. So this is where the merge is required. Now let's see in pcap how to merge this. So I have one test one, and I have another file called test two. Now, uh, now here I have option file merge option is here. So here I am merging test one with test two. So test two. So merging is going on. It takes some time to merge both the files. So the file ultimately got merged. So let's see what is there in test one. So let's take an example of test two. So test two, I have this call. Now let's apply this, and so I have filtered this call. So I want to check whether this call is there in test one. So I am filtering with the same data in test one. There is nothing. Now I have merged these two to this file. Now if I will check, so I can find. So these two files are merged together. So this is where the merge comes. Merging is required, where we have to merge multiple files to get one file, and from that one file we can get the full call related details. I'll say okay. So let's start how to debug SIP signaling with wireshark or tshark. So I have captured the data in a pcap file. Now I want to analyze the data using the tshark file. So to analyze the data, I there are so many filters and so many ways are there. So let's focus how to do. So here I have made a call, and I have captured full trace on Ethernet. So it captured all the data, like it captured TCP, it captured TLS, it captured UDP packets, it captured SIP packets. So now I have to separate out these data for my uh, purposes. So let's now there are filters, like I can filter with protocol. Now I filter with SIP protocol, it will show me only SIP messages here. So here I can see all the SIP messages. Now related calls I can get from here, and I can filter it out. Now to filter this, there are various options, like if I want to filter a specific call, I can filter it with the call ID, because all messages, the call ID is common to all. So here I can right click and I can apply filter as selected. So it will filter all the messages related to this call ID. That means the full call will get filtered. So I can see from these that the invite, 100 trying, 180 ringing, 200 okay acknowledgement, all these things are sent. So there are other options, like there are so many filters you can put here. You can put like your port based filtering, like I can put udp dot port into 5060. So all the data to 5060 port will be get filtered here. So similarly I can do TCP port filtering, I can do RTP port filtering. So these are various filters available. I can do IP based filtering also, like IP dot address I can put like this. So it will filter all messages related to this IP only. Then we have option for, and if we want to put TCP dot port this IP and port UDP dot port. So it will filter from this IP and this port. So these kind of filterings we can put in wireshark. Now, if I want to debug the signaling flows of a VoIP call, voice SIP call, so the best way is to do is like this. There are VoIP calls. It will automatically filter out all the. It will filter and it will show you all the calls. So here I can click the first call. I can see what is the flow sequence. So to see flow sequence, I can see here. So what happens is here I see that the call establish which IPs the call goes through, whereas the media IP from which media IP it got established call. So all these things I can see here. So this is how it works. If you want to filter only this call, you can do prepare filter. It will filter out the full signaling and media related to this call. So this is how the signaling related stuffs are filtered out and media related things are filtered out. Now, now let's see. So this will show you the full call flow, how the call worked, what are the invite message sent, what are the. So for further analysis, you can save as, you can do a save as and all this. So here are more options you can see, like if you can do a prepare filter. Here you will see all the messages. Now in all the messages you can go through the message, full message flow, the message headers, the request headers and the message body. So this will give you all the details of what are the messages sent, what are the headers, data, IPs, all this you can see here. So as a beginner it will be very useful to understand how the messages are sent, what are the messages sent, and how the STPs are sent, where which IPs are sent, from which port these are sent. So I am not going to details in SIP messages. I am just showing how the messages are sent. So these details I will give another video where I will describe each and every header, each and every properties, every attributes, all these things I will describe in another video. So this video I am just giving an introduction how wireshark, how the tools we can use for debugging purposes. So this is how we will debug the signaling messages. So now let's see. So now come to debugging the media issues. Media issues, mostly the voice issues. So this is very big topic. I cannot cover in this video, but I will give a brief introduction how to see the media and how the media works and how to analyze the media issues. So let's see my last call here. Okay, so let's take an example of this. So this is my call. and I want to debug the voice issues. The voice issues means when there are some voice cracking, some voice disturbance are there, how you will debug those issues. So basically, when you do a full capture, full media and signaling capture, the wireshark will capture the audio packets also. So you can playback those audio packets from here. So you just select that specific call based on the time or number. You know which call has issue, so you select the call, and you can see there is option for playing the streams. So it will show you the full streams. So you can playback the stream, and you can see from which IP to which IP the media issues are there. So based on that, you can decide whether the media issue is from the trunk, or is from your server, or is from your application issue. So listening to these audios here and seeing the IP addresses and port from where to where the media issues are there. So these kind of issues you can easily analyze using this. So let's play this. This one is a test case. I'm testing for bus analysis. This test. So this is how the media will be played, and you can listen to these media packets, and you can understand how this what are the issues with that call. So I am not going to details. I am not going in details for this now, because OS issue debugging is a very huge. It requires huge time. So I will release another video how to what are the how the voice issues are generated, why the voice issues get generated, how to debug the voice issues. Here I am just showing a brief analysis how you will get the voice part analyzed from the wireshark. So this is how it works. So here you can get the voice related packets. Now there is another way for getting the voice related packet is RTP. Here you can see the RTP streams. So based on the port, like let's first do filtering of one call. Now how I will get the RTP streams, and how will know which RTP stream belongs to which call. So let's prepare filter. So here I can see the invite message. So these are the SIP messages. So in invite message, it will send you the port number 50302. Similarly, in 200 OK, it will send the port number 15426. So based on this, I will know that from which port the audio is playing, and based on that, I know which port belongs to which call, and which call I have to debug. So let's see 50302 port numbers. So here also you can put the filter like udk.port 50302. So I can see when I filter with 50302, I can see all the uh, RTP packets, because this port is RTP port which is negotiated during call. So this is the RTP port where the media is established. So I can see both way from it will show you both way from these to these and reverse. So if you go through all the packets, you will see here you got the reverse packet. So if you filter with UDP this port, it will give you all the ports from and to. So let's now figure out how RTP option will give me this. So here if you go to RTP streams, so here you see 50302 port is there, and reverse port is there. So these are the RTP packets for this call. So now if I will analyze, I will get all the RTP packets from these two and from this port. So here also I can do the similar play. Now in your this one is a test case. Okay. I'm testing for voice analysis. So here I have in my call. So let's see this call. This is 870 calls. So here I have selected one way because in same server both the phones were there, so it's echoing. Now I am selecting one stream only. So here you will not get any echo because I have this one is a test case. It's echoing back because I have put it in same server, same machine, both the phones. So here I have selected one stream only from these to this. So this way we can separate out the streams so that we will know exactly from which IP to which IP, which port to which port media is flowing, and we can easily figure out from which port to which port the media issues are there, from which IP to which IP media issues are there. So this way we can debug the voice issues. So I mean these are some examples how wireshark will debug the voice issues. So now let's see one more example. Here I have this is a successful call flow. Now I am discussing about a failed call. So here I have called from A to B and B rejected the call. So how this works? So if I see the flow sequence, so here 180 ringing, then it sent a 503 unavailable, so it rejected the call. So here is a failed call. So we can similarly prepare filter. So here I have used asterisks for this. So here I have got the course code and all this. So there are ways where you will get the SIP course code is 503, and with 503 you will get the Q850 course code also. Like some of the operators, if you are connected to SIP trunk, or PRIs, there you will get the SIP course code with the PRI course codes where X850 course codes will be mentioned with the PRI course codes like 1917 if BZ 503 is service unavailable. So accordingly we will get the PRI course codes. So now let's see the next topic. So capturing the DTMF. So in SIP, there are various kinds of DTMF, but few DTMFs we can capture on wireshark capture. Like there are DTMF like SIP info DTMF. I will give details on DTMF also in another video. Here I am just showing how to capture the DTMFs in wireshark. So the SIP info and RFC 2833 DTMF we can capture on wireshark. So here I have shown how RFC RTP events are getting captured like DTMF 3, DTMF 8, DTMF 7, all these things are captured here. So let's see how it captured in wireshark. So here I have already captured one file for RFC. See this file. Here I have one call where I have captured DTMF. So if you open up this flow sequence, it will show you the DTMF, how DTMF are captured. So here DTMF you can see. So this comes as an RTP packet. When RFC 2833 is there, it comes as an RTP packet, and these RTP packets get captured in wireshark or tshark. So here, if I will do a prepare filter, so I can see that the RTP packets are captured as an RTP event. These are voice events, but this is RTP event, and this RTP event is audible in wireshark trace. So every digit that I have pressed, these are getting captured as RFC 2833 DTMF. So here I can see the DTMFs, DTMF4 is pressed. So this is very useful when you are debugging the IVRs, like sometime IVR DTMF not getting captured, so you can take a trace, full trace of RTP, and you can see whether the DTMF really passed to the application or not. So here, these are very useful while debugging the production servers where multiple calls are running and you want to debug a specific call where DTMF is not getting captured. So these cases you can run a full RTP trace and you can capture those events, and later you can see whether the whatever DTMF you have pressed are those really captured in wireshark or not. Based on that you can debug whether it's an application issue or it's a telco issue whoever not sent the DTMF. So this is how the RFC 2833 DTMF getting captured. So there is another DTMF mode is there which is called SIP info DTMF. So let's see. So here now let's show one small thing, like this is one soft phone called Bria soft phone. It has options like preferences. You can select what kind of DTMF you want to send. Like if you want to send RFC 2833, or if you want to send SIP info or invent DTMF or whatever, or you want to send dynamic, select dynamic DTMF. Like that you can option. So to capture all this, I have once set info DTMF, another time I set RFC 2833 DTMF, so it send the RFC 28 and info DTMFs accordingly. So here I have captured some SIP info DTMF. So if you see here, so here you can see that the DTMFs are sent as a signaling message. Previously I have sent it RFC 2833 where media is sent as an RTP packet. Now it is sent as a signaling packet. So here one info message is sent, and that info message is carrying the DTMF. So if I prepare filter, so here you can see, so better not to prepare filter like this. So let's do it like this. So here I can see that the info DTMF is sent. So signaling 2 is sent, signaling 3, 1. So this is how the info DTMFs are captured in wireshark for debugging purposes. So this is all about SIP and VoIP debugging. I hope this video will give you a clear idea about how to debug the SIP messages, DTMFs, VoIP messages, how to capture the RTP packets. So, so just go through this video and you will get a good idea about it. So guys, thank you for seeing this video. If you like this video, please don't forget to like, share and subscribe to my channel. I will give more videos like this, details videos where you will be able to get good ideas of how to capture and use telecom messages, how to see, and I will give good introductions of other things as well. So guys, don't forget to uh, like, share and subscribe to my channel. It will give me energy to put more videos like this. Thank you guys.